Hello there. In the previous videos, we have discussed briefly different types of samples from those populations. Overall, the study of statistics is about making inferences about the population for which we are sampling from. And there are different ways to make inferences and different measurements we can use to do that. One of those measures is called the measure of central tendency. Another measure is called the measure of variation. There are a few other measures that we will use throughout this series, but in this particular video we will be focusing on the measures of central tendency. Alright, so to begin, what is a measure of central tendency? In general, it describes where the middle or the majority of the data is, and or lies around with respect to the remainder of the data. There's different ways to represent the middle, or the area for which the majority of the data lies in. So let us introduce four of the most common types. So the first one is called the mode. The mode, simply speaking, is the most frequent data value. The second most common measure is what we call the median. So the median, which some people also refer to as the 50% quartile, and we'll talk about quartiles a little bit more in detail later, and this is the middle element or elements of an ordered set of data. So let's begin with a basic example to sort of illustrate these two measures of central tendency. So example, let's consider the set given by the numbers 4, 4, 4, 5, 5, 6, 7, 7, 8. So these could be, say, the ratings from 0 to 10 of the movie that just came out at your local movie theater, right? So first off, what is the most frequent data point in this value? We clearly see that the frequency of 4 is 3, and the frequency of the rest of them are either 2 or 1. So since 4 has the highest frequency, we can say that the mode of this particular set S is going to be equal to 4. So let us also consider the median. So clearly all of these values are listed from least to greatest, and if it is not, be sure to do so before you try and calculate the median. So we clearly see that this is 1, 2, 3, 4 data values, and then we have 4 data values on the right-hand side, leaving 5 in the particular middle. In particular, notice that the number of elements in this set is odd, and if that is the case, you will always be able to do that. So since 5 is in the middle of the data set, we can say that the median of this particular data set is equal to 5. Now let us consider a particular example for which you do not have an odd number of data sets. In particular, let t be equal to 4, 5, 6, and 7. In this particular example, we see that there is no most frequent data point. So we may say that the mode is undefined, or that the mode doesn't really tell us anything in this particular case, since 4, 5, 6, 7 all have the same exact highest frequency, in this particular case 1. For the median, notice that we have an even number of data sets, so the size of t is even. So in this particular case, what we do is we take the average of the middle two data points, right? So in this case, the median of set t is going to be the average of 5 and 6, which in this case is going to be 5.5. Let us introduce the other two measures of central tendency. So the third is what we refer to as the mid-range, and the mid-range is going to be the average of the minimum value and maximum value, right? So if we use this particular example t, we can say that the mid-range of t is going to be equal to the average of what two numbers? So the minimum of the set is 4 and the maximum of the set is 7. Therefore the minimum is going to be the average of 4 and 7. So 7 plus 4 is equal to 11, and 11 halves is equal to 5.5 as a decimal. So you can express this as either a decimal or fraction. Typically it does not matter, it depends on where you're going to use this number for. So the next is what we refer to as the arithmetic mean. Some people just call it mean, but there's another mean known as the geometric mean, which we will talk about later, right? So this is going to be the average of all data values. So if we use that same exact set T, so the mean of that particular set T is going to be the average of 4, 5, 6, and 7. So 4 plus 5 plus 6 plus 7, if you average that out, again you will get 5.5. And again, there is a fifth, another common measure of central tendency, known as the geometric mean. And we will define and talk about this a little bit later because it pretty much has some special cases on when it can and cannot be used, right? So we'll discuss this later, right? So let's talk about this arithmetic mean just a little bit more because this is often used in a lot of data analysis, especially in this particular statistics series, right? So as we were talking about before, we usually have a sample that's a subset of the population. Now let's assume that the size of S is equal to little n, and the size of our population is going to be equal to capital N. And we've already determined why little n is always going to be less than or equal to big N. So if we want the mean of a particular sample, usually we abbreviate this by x bar. And if we want the mean of a population P, we usually represent this by Greek letter mu, right? So this is Greek letter mu, right? So this is our statistic because it is a measure on a sample, and this is of course a parameter because it is a measure on the population. So how do we calculate the mean of a sample? So as we said already before, it's going to be the average of all of the values in our sample. So this is going to be the sum of the x values divided by our sample size. Here, x must belong to our sample. So that's the formula for the sample mean. And similarly for the population, similar formula. So mu is going to be equal to the sum of all of the x values divided by capital N. Here, x must belong to the population. Right? It's pretty much the same thing, but the formulas are subtly different. Right? So here's a question. So question, which measure of central tendency is best? So there's usually two criteria that people usually use to determine which measure of central tendency we want to use. The first criteria that we usually consider is data representation. So when I say data representation, I mean how many points do we actually consider when we actually go through the calculation of it. So the least, I guess the least qualified of those four measures of central tendency that we discussed would happen to be the median. So why is the median the worst in terms of data representation? Because we're only considered with the middle position regardless of its value. So we can change all of the other values around the median and maybe even, no, we can keep the median value the same. But if all the other values change, as long as they're listed from least to greatest still, then the median will not change. And that's problematic. So the next value that is not so good, but it's not as bad as the median, I guess, would happen to be the mode, right? This at least considers the most frequent value. So now we've started to consider the values of data sets. The third, you want to take a guess? What is the third best, or the third worst in this case, or the second best? That would be the mid-range. How many values do you need to consider for the mid-range? That's two values, the maximum and the minimum. And the best, in terms of data representation, will be the arithmetic mean. So the arithmetic mean, right? Because we consider all values in its calculation. Another characteristic that we usually consider in terms of which is the best measure of central tendency would be what we call the resistance to change by either a single outlier or outliers. So what is an outlier? We'll discuss and firmly define this a little bit later, but it's number or numbers that are really different. That's a subjective term, which will, solidify a little bit later, but it's really different from the others. So for example, if you have test scores like 38, 42, 39, 26, and 97, we would most likely classify this 97 as an outlier because the rest of the data points are extremely far from it. So if you introduce an outlier, how much will the other measures change, right? And we're going to look at this and analyze this in a little bit more detail later, but the worst will be the mid-range. So why is the mid-range the worst in terms of resistance? That means the mid-range will change the most out of the four when an outlier is introduced. Usually an outlier is either on the extreme ends of the distribution. Either it's going to be at extremely high value or an extremely low value. And remember, the mid-range only considers the maximum and the minimum, so most likely that outlier will be one of the numbers that the mid-range uses to calculate. The second value that's going to change the most will be the mean. Right? So the best number in terms of data representation is actually not so good when it comes to outliers, right? And why is that the case? Well, yes, the average considers all of the values, and that's of course going to include the outlier. So sometimes when you calculate the mean, identifying the outliers first and then removing them is sometimes a way to go about it, but I don't recommend it for all cases because that's a very sensitive issue when you start messing with your data. Now, the mode and the median are technically tied in terms of resistance, right? So I'm going to put mode down here, and I'm going to put median down here, because if the outlier is introduced, that means it's really different from the rest, right? So the mode represents the most frequent, right? So if another number is introduced and it's really different, it can't really be a mode because the mode is already a value that's most frequent in the data set. The median is not really going to change much because it's the middle position, right? So if you add one number, then the position will change at most once, right? So we'll shift over to the next number to the left and or on the right, depending on where the outlier is introduced. But the mode doesn't really consider the values, so I would probably choose median over the mode in terms of the resistance to outliers because, there's many reasons why. But in terms of resistance to outliers and the representation of data, I would definitely choose the median if there are any outliers being used. Or maybe you want to do the average of the arithmetic mean and median. There's different variations. Anyway, this is just a quick overview of the different measures of central tendency, the four most common ones. Again, there's a fifth known as the geometric mean, which we will talk about later. And I've also given you a couple criteria that you can use to sort of rank which measure of central tendency you want to use in terms of data representation and the resistance to change by outliers. Hope you enjoyed. As always, if you enjoyed, please like this video, consider leaving a comment, and if you enjoy the channel content, please subscribe. We publish several new topics every single week. Thank you.